Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 10 of CIE P3 9709 May June 2021 paper 3 variant 3. And this particular question is based on the topic complex numbers. So in part A we need to verify that -1 plus under root 2i is a root of the equation z raised to the power 4 plus 3z square plus 2z plus 12 is equals to 0. All right. So what we are going to do, we are going to substitute this root into this equation, and therefore we will prove that it is equals to 0. All right. So as we know that z is equals to -1 plus under root 2i. So obviously we need z raised to the power 4 as well and z square as well. So I'm going to do some working for finding z square and z raised to the power 4. So z square will be equals to -1 plus root 2i whole squared. So this means z square will be equals to a square plus 2ab plus b square, and in place of a I'm going to write -1, and in place of b I'm going to write under root 2i. Okay, so therefore we can say that z square is equals to 1 minus 2 root 2i plus 2i square, and since I square is equals to -1, therefore z square will be equals to 1 minus 2 root 2i plus 2 times -1. So z square is equals to 1 minus 2 minus 2 root 2i. Therefore z square is equals to -1 minus 2 root 2i. So now we are going to find z raised to the power 4. So z raised to the power 4 is the same thing as saying z square is squared. So therefore in place of z square we are going to write -1 minus 2 root 2i, and this will be whole squared. So therefore a square plus 2ab plus b square. So in place of a I'm going to write -1, and in place of b I'm going to write -2 root 2i. All right, so this means 1 and then plus 4 root 2i and then plus 8i square, and since I square is equals to -1, so 1 plus 4 root 2i plus 8 times -1, so therefore -7 plus 4 root 2i is z raised to the power 4. So now what we need to do, we need to substitute z squared and z raised to the power 4 into the equation. So in place of z raised to the power 4, we are going to write -7 plus 4 root 2i and then plus 3 times z square, meaning 3 times -1 minus 2 root 2i, and then plus 2 times z, and z is -1 plus root 2i, and then plus 12, and we are going to see if it comes equals 0. So this must definitely come equals to 0. And once it is equal to 0, so therefore the process of the verification is completed. Left hand side will be equals to right hand side. So we are going to expand and simplify the terms. So -7 plus 4 root 2i minus 3 minus 6 root 2i, and then -2 plus 2 root 2i, and then plus 12. So 4 root 2i minus 6 root 2i will become -2 root 2i, and then we will add 2 root 2i into it. So the terms in I will cancel out. So in one step, we can say that -2 root 2i plus 2 root 2i, and then -7 minus 3 becomes -10, and then -10 minus 2 becomes -12. So -12 plus 12, and therefore it is equals to 0. All terms cancelled out, and therefore the process of verification is complete. Left hand side is equals to right hand side. So now we are going to solve part B on the next page. part B says that find the other roots of this equation. So as we know the fact that the polynomial z raised to the power 4 plus 3z square plus 2z plus 12 is equal to 0. This equation is having the real coefficients. Okay, so the complex roots will come with conjugate pairs, and since we already know that z is equals to -1 plus root 2I is a root of this equation, so therefore the other complex root would be the complex conjugate, of this root. So the other complex root would be -1 minus root 2I. As simple as that. So now what we have two roots and both of these roots are complex. So we are going to obtain a quadratic equation. Such quadratic equation, if you solve that quadratic equation, you will get these two complex roots. So how do we actually find this type of equation? As you know the fact that any quadratic equation which is given to you in a generalized form, how do you actually find it? X square minus sum of roots times x plus the product of the roots. Okay, so here we have the variable z, not x. So we are going to say that z square minus sum of roots times z plus the product of the roots. So first of all, we are going to find the sum. So the sum would be -1 plus root 2I plus -1 minus root 2I. Therefore, -1 plus root 2I minus root 2I. So root 2I and minus root 2I are cancelled out. Therefore, the sum of the roots is -2. And now we will find the product of the roots. All right. So the product of the roots would be -1 plus root 2I multiplied by -1 minus root 2I. So therefore, first of all, -1 into -1, so this is 1, and then -1 into minus root 2I, this is supposed to be positive root 2I, and then root 2I into -1, this is supposed to be minus root 2I, and then root 2I into minus root 2I, this will be minus 2I square. And since I square is equals to -1, so 1 plus root 2I minus root 2I minus 2 times -1. So therefore root 2I and minus root 2I are cancelled out, and therefore you are left with 1 plus 2, which is equals to 3. So therefore the product of the roots is 3. So now we can say that the quadratic equation which you solve and get these two complex root, that particular quadratic equation will be z square minus 2 times z plus 3 is equals to 0. So therefore z square plus 2z plus 3 is equal to 0. When you solve this particular quadratic equation, you will get these two roots, -1 plus root 2I and -1 minus root 2I. So now, as we know the fact that the polynomial which is given to us in the question, z raised to the power 4 plus 3z square plus 2z plus 12, when it is divided by z square plus 2z plus 3, it will give us a remainder of 0. So we can say that z raised to the power 4 plus 3z square plus 2z plus 12 is completely divisible by z square plus 2z plus 3. So what we are going to do, we are going to use the long division method in order to find the quadratic quotient, since the polynomial with a degree of 4 is divided by a quadratic divisor. So the quotient will also be quadratic. But you need to make sure to write the terms in correct sequence in the polynomial when you are doing the long division method. So in this case, as we can see that after z raised to the power 4 term, z cube term is not given to us. Okay, so when you are doing long division method, you need to follow the strict sequence. So we are going to write the polynomial like this: z raised to the power 4 plus 0 times z cube plus 3z square plus 2z plus 12. And then we will write the divisor, which is z square plus 2z plus 3. So first of all, z square into z square will give you z raised to the power 4. So z raised to the power 4 comes exactly underneath z raised to the power 4. And then z square into 2z, it will give you 2z cube. So 2z cube over here, and then z square into 3. This will give us 3z square. All right. But right now, as we can see that elimination is not happening. But if we multiply this expression, z raised to the power 4 plus 2z cube plus 3z square with a minus sign, so this becomes minus minus minus. So z raised to the power 4 and minus z raised to the power 4 is cancelled out. And therefore you have minus 2z cube plus 0z square plus 2z. All right. And then here we have three terms and here we have three terms. So we are going to continue the same process. So z square multiplied by what? So that you get exactly minus 2z cube. Obviously, when z square is multiplied by minus 2z. So minus 2z cube is underneath minus 2z cube, and then minus 2z into 2z, this will be minus 4z square, and then minus 2z multiplied by 3, this will be minus 6z. And then we will multiply this expression with a minus sign. So this becomes plus, plus, plus. So minus 2z cube plus 2z cube cancel out, eliminated. And then here we have 4z square plus 8z. And then this 12 will be carried down. Okay. And then z square into 4 will give you 4z square, and then 4 into 2z will give you 8z, and then 4 into 3 will give you 12. And since we already knew that the remainder will be equal to 0, so if we multiply this expression with a minus sign, so all of these terms become negative, and therefore the remainder is 0. All right. So now we can say that z square minus 2z plus 4 is the quadratic polynomial. It is the quotient. So in order to find the remaining roots, two roots we already have. Okay, we have the two complex roots, which we already know. But now we are going to solve this equation. Z square minus 2z plus 4 is equals to 0. And then we will see that we get complex roots or real roots. Okay, so z is equals to minus minus 2 plus minus under root of minus 2 square minus 4 times 1 times 4, and then it is divided by 2 times 1. So z is equals to 2 plus minus under root of what? 4 minus 16 will give you minus 12, and then it is divided by 2. So we will get the complex roots since the discriminant is less than 0. So in place of minus 1, we are going to write I square. So this is supposed to be z is equals to 2 plus minus under root of 12i square divided by 2. So therefore we can say that z is equals to 2 plus minus under root 12 into I completely divided by 2. So far we have achieved this thing. So under root 12 is exactly equals to 2 root 3. So z is equals to 2 plus minus 2 root 3i divided by 2. So now we can factor out 2. We can take 2 as common. So z is equals to taking 2 as common multiplied by 1 plus minus root 3i completely divided by 2. Therefore, z is equals to 1 plus minus root 3i. So therefore, we can say that other roots are, the first one was the complex conjugate of the root which was given to us in the question. So the other roots are minus 1 minus root 2i, and then minus 1 plus root 3i, and then minus 1 minus root 3i. So the equation which is given to us in the question has 4 complex roots. So this is supposed to be your final answer since we were required to find the remaining roots. So this was question number 10 of CIE P3 9709, May June 2021, paper 3, variant 3.